Section 8.4, confidence intervals for a proportion. When we create a confidence interval, we're going to follow this four-step process. First, we're going to state the parameter and what level of confidence we're going to use. We're going to identify the method and check the conditions. If those conditions are met, we'll perform the calculations, and then we'll finish the interval by interpreting it in the context of the problem. A confidence interval for a population proportion is often called a one sample z interval or a one proportion z interval. So as an example, Sleep Awareness Week begins in the spring with the release of the National Sleep Foundation's annual poll on U.S. sleep habits, and it ends with daylight saving time. We have a sample of 1,029 U.S. adults, and in that sample, 48% reported that they often or always got enough sleep during the previous 7 nights. We're going to construct and interpret a 95% confidence interval for the proportion of all U.S. adults who would report that they often or always got enough sleep. The first step in creating a confidence interval is to state the parameter and the level of confidence that we'll be using. So here we're going to create a 95% confidence interval for P, which is the proportion of all U.S. adults who would report that they often or always got enough sleep from the previous 7 nights. Remember, when we're making a confidence interval, we're using the results of a sample. In this case, it's the 48% of the 10,029 adults in our sample. And we're using that to get some kind of estimate about the whole population of all U.S. adults without actually having to go and talk to all U.S. adults. Next step, we're going to note which inference method we're using. This is a one proportion z interval. And we're going to check the conditions. So we have a random sample of 1,029 U.S. adults. That's less than 10% of all U.S. adults. And we want to check that success-fail condition, n times p and n times q, and see that those are both at least 10. With those conditions met, we're going to perform the calculations. So we use this equation here. We start with our point estimate, p hat. That's the result of our sample. We have our critical z-score, which comes from the level of confidence. In a 95% confidence level, we put that 95% right in the middle. And we're going to add in the area in this left tail here. Okay, so this left tail is half of what's left over. So if there's 95% in the middle, there's 5% left over, and that's split in half. So 2.5% on the left, 2.5% on the right, and then we look up that value in the table. Okay, that's going to give us a critical z-score of negative 1.96, and we'll just change that to a positive. So we have our p hat of 48%, we have our critical z-score, and then we have p hat q hat over n. Our margin of error here we can simplify to 0.031, and then as a last step we're going to add and subtract that from the point estimate of 48%, and we get an interval of 0.449 to 0.511. We finish things up by interpreting this interval in the context of the problem. We are 95% confident that the interval from 0.449 to 0.511 captures the proportion of all U.S. adults who would report that they often or always got enough sleep during the past 7 nights. Now, the wording of this interval is specific. We're talking about the people who would report that they got enough sleep, and we're not talking about the people who reported that they got enough sleep. If we use any kind of past tense language here, like reported, we're really talking about the sample proportion, the people who were asked and answered the question. So we always want to make sure that we're using language that makes it clear we're talking about the whole population of all U.S. adults, most of whom weren't asked this question, what proportion of them would report that they got enough sleep. Does this interval provide convincing evidence that a majority, meaning over 50% of U.S. adults would report that they often or always got enough sleep? Well, if we look at our interval here, there is a portion of it that's above 50%, but there's other parts of the interval that are not above 50%. So really what we're looking for with this type of question is this value, 50%, inside this interval? And if it's anywhere in the interval, we'll have a portion that's above it and another portion that's below it. Okay, so better for us when answering this question is if it's outside the interval. So if this was, say, 0.499 and 50% was out here, then we could say we're 95% confident that less than half of people in the US get enough sleep. So with this 50% in the interval does not provide convincing evidence that the majority of US adults would report that they often or always got enough sleep. Oftentimes we'll want to create a confidence interval around a given margin of error. For example, we might want to estimate the proportion of people who work from home, where our estimate ends up within 3% of that true population proportion. If we take a look at the equation for margin of error, the z-score times that standard error of PQ over N. Obviously, this includes the value of p hat in its calculation. And the issue is that most of the time, we don't know what p hat is until we actually take our sample. And what we're really trying to do is figure out how many people to sample, so we haven't taken our sample yet. So in situations like that one, we kind of have to guess what p hat is, and there's two ways that we can go about this. So the first is that we can use the results of an earlier sample. So if we can find an old sample about the proportion of people who work from home, we'll look at what their p hat was and just use that for our calculations. If we can't find any other studies, we're going to use a value of 0.5 for p hat, which would also mean that q hat is 0.5. This is a worst case scenario. Margin of error is going to be the largest if p hat equals 0.5. So if it ends up being anything else, we just result in a smaller margin of error, which is good for us. So once we pick our p hat, we can do the calculations and figure out what size sample we need to take in order to get a margin of error within 3% or whatever it is for our desired margin of error. So let's suppose that we want to estimate P, which is the true proportion of students at your school who have a tattoo, with 90% confidence and a margin of error of no more than 7%. So the question we're trying to answer right now is how many students do we have to survey to get a margin of error within 7%? So we'll start off by figuring out what values we can plug into our equation. We don't have any past study on the proportion of students who have a tattoo, so we're going to use p hat as 0.5. That's our worst case scenario. This 1.645 comes from that 90% confidence interval, where we put 90% in the middle of our curve here. We split the leftover portion in half, so 10% is left over, 5% is on the left side, and we're going to look up that value, 0.05, in the middle of our yellow table. Okay, it ends up being right in between 1.64 and 1.65, so that's our critical z-score. Right? P hat is 0.5 along with the q hat, and the margin of error is 0.07. Make sure we're writing this as a decimal. It sometimes gives it to us as something like 7%, and we need to switch it to a 0.07. Now we're going to solve this algebraically. So we'll start by dividing by 1.645 to cross these guys out. It ends up on the other side with that 0.07. All right, and then we're going to square both sides to get rid of that square root. So these would cancel. Over here we have that fraction squared. Next, we're going to multiply both sides by n to move that n outside of the denominator. And as a last step, to get the n all by itself, we're going to divide it by this entire fraction here. So when we do that, we get our answer, 138.06, and we're always going to round this number up. So we need to survey at least 139 students. Now note, this number is a lot closer to 138 than 139, but it doesn't matter. We're still always going to round it up. This is the number of people that we need to survey. And once we start talking about a portion of a person, we need to take the entire next person. If we rounded it down and found the margin of error, we'd get 0.07002, which is really close to 7%, but it's not meeting that criteria of a margin of error of no more than 7%. So we always round this to the next highest integer, even if it's really close to the lower number.